Good morning, everybody. How are you doing? I'm just confirming the midterm exam date and time. So I'm gonna write it in the chat box. All right. So midterm, you all know that it will be conducted in campus, right? So midterm exam for this course will gonna be Sunday, 8th of May, 2022, and it will be at 5 p.m. All right, it will cover chapter 1, 2, 4, and maybe in part, or maybe chapter 12 also. So this will be confirmed later, okay? I'm gonna write chapter 12. Then this will be confirmed. Okay, so the midterm exam will be conducted in campus. Okay, and it will cover chapter 1, 2, 4. Chapter number 3, inshallah, we are going to cover it later on. For now, we are doing chapter number 4. So 1, 2, 4, and chapter 12 will be covered in the midterm exam, and it will be conducted in campus at in Sunday, or on Sunday, 8th of May 2022 at 5 p.m. Any question about the midterm? Any question? The questions type will be multiple choice, true, false, maybe there might be matching, and essay questions. Do you have anything? Anything about? It's 8th of May because you know why? It's very I know it's very far from now, but see, because it will be conducted on campus, and they send the coordinator, Dr. Ahmed Zaki, 2 options only. One is very soon, and the other one is 8th of May. So that's why this is the only option that we have. All right, so it's okay. We are going to have some quizzes, some activities. All right, so don't worry about it. Any other question? All right. Okay, perfect. All right, all right. Yeah, I hope you all are happy with it. Okay, till then you will have more activities, you will have more, which means practices over the, I mean, you will have more reading, and you will get more knowledge, okay? Get to know all more concepts. So I'm gonna also provide you some links or activities related to other chapter slides. I'll give you some scenarios, some papers, all right? So you will have more understanding. You will get more understanding. Okay, let's talk about the relational model today. So today we're going to discuss relational model. Before we go through this, who can tell me what is the relational model based on what we have covered previously? You remember that we have 3 types of data model. Yes, I guess yes. Yusuf, it will be 1.5 hours for the midterm. Maybe 1 hour or 1.5 hours. But mostly we have it 1.5 hours for the midterm. exam. You are welcome. What is the relational model? Okay, Alia, using a structural language consistent with first order. Okay, you remember, refer to what we have covered, what we have discussed previously. We said there are 3 data models. What are they? We have object-based, record-based, you remember? Object-based, which represents data as entities, relationship, and attributes. So object-based means it will deal with every object, or sorry, every entity as an object, distinct object. And it might be a thing, it might be a person, and so on. All right? While record-based, it's something like representing the data or data of the database as relations or records, right? Records as tables, you remember? So based on that, we know that the relational model, we are going to focus on which one? Object-based or record-based? Yes. Object means entities, attributes, like what we have, like what I drew before, a rectangle shape. While relational means relations, right? Relations. What does it mean, relations? What does it mean? Anyone? Relations means focus. Object-based. Object means entities. We are representing data as entities. Rectangle, there are relationship between them. Okay, object-based as an object, distinct object. While relational or record-based, yes, Mariam, excellent. Thank you for that. So relational model, it means that we are going to discuss about tables, okay, or relations. So representing data as relations or tables will be a relational model. All right, so now you have an idea about what we are going to cover today, right? Relational model, representing data in a database as relations or tables. Okay, thank you, Maria. Now, the objectives of this chapter slide will be, we are going to discuss the terminology of relational model, how tables are used to represent data. Okay, so we know that relationals, or relational models means this is, let me just write here, relational means relations, relation equal tables. Okay, put this in your mind. So relations means tables. Okay. Connection also, we are going to discuss the connection between mathematical relations and the relations in the relational model. So how we can compare between them, or what is the connection? What is the link between mathematical relations and relations in the relational model? Then we will discuss the properties of database relation. What are the properties that we can see for each relation? There are some or certain properties. Then how we can identify the type of keys. You mentioned 2 types of keys before. We need to identify 3 types of keys: candidate key, primary key, and foreign key. Yes, exactly, Ali. So we have 3 types of keys. We can use them in terms of constraints over the relations. So we can have candidate key, which is CK. CK stands for candidate key. Primary key stands for primary, PK stands for primary key, and FK stands for foreign key. All right, so 3 types of keys we're going to discuss. Then we will look at the meaning of entity integrity. There are 2 types of constraints in the relational model. So these are constraints. Let me just, these are constraints: entity integrity and referential integrity. Okay, so these are 2 types of constraints we can apply on the relation. What does it mean by saying entity integrity or referential integrity? Then we will discuss the purpose and advantages of views. Maybe this one, you are familiar with this term, right? Views. What does it mean? We are going to discuss it in more details, mentioning the advantages and the purpose. All right. So that's all for this chapter slide. It will be short chapter slide. You can see it contains only 36 slides. All right. Now let's talk about the terminology of the data model. We can call this the system or the database system RDBMS, which means Relational Database Management System. All right, Relational Database Management System, and it can be used as a dominant data processing software in use today as well. So we are using the Relational Database Management System, and per year the sales are from $6 to $10 billion US dollars, which means very popular, and it's based on the relational data model proposed first by Code 1970s. So this is just to let you know that this is the first relational data model proposed. All right. What was the first generation of database management system? It was the network and the hierarchical database management system. You remember when we talked about the types, we said we have different types. We have network, hierarchical. So the first database management system for the relational, for the record base, was the network and hierarchical database management system. Now, what is the main objective of the relational database management system? To allow high degree of data independence. This is the first one. Okay, this is a main objective, and to provide substantial grounds of dealing with data semantic consistency and redundancy problems. So all data semantic will be handled by the relational. Just let me highlight this. Okay, the relational database management system, it will be handled nicely by the relational database management system. So 2 objectives of having relational. Why we need to have relational database management system? Because it's used to ensure high degree of independence or data independency. Then to handle data semantic consistency and redundancy problems. We have nowadays we have hundreds or several hundreds of relational database management systems. Some of the extensions of relational models supporting object-oriented concepts, and some supporting deductive capabilities. All right. Now let's talk about the terminology. How we can represent data as in the relational data model. A relation. So we said relation, or alternatively, we said we can call it table, right? Or file. So how many? We have 3 terms to represent data. In the relational model, it can be known as relation or table or file. So what is the relation? Relation is a table including number of columns and which are attributes or fields. We can call them attributes or fields. See, we can have it like, see here, if we have file means relation, means table. Okay. Alternatively, we can call just a minute. Here in the file based, we can have tuples or records. In the file, we have attributes. Or we call which call this? Let me have records, not records. Records in the table. Okay, let me just write this one. Attribute is equal to fields. In the file, there are fields equal to attributes. Or in the table, they are columns. Okay, this is the right way. So see here, in the file, it includes number of fields. Same, relation, attributes, table, columns. All right. And we have here rows, tuples. All right. Equal tuples or rows. We can call it rows, tuples. And then we have records. Then same with rows. Okay. So we can have this. These are alternative terms. Same. So in the term relation, we can have number of attributes. All right. And each attribute will have records. This one. Yeah, each attribute will have records. Same as file. In the file term, in terms of files, file will include or contains number of fields and will have number of tuples. Same. Alternatively, we can say table includes number of columns and rows. So this way, you can know or understand all these terms. Okay, got the point? So this is how we can understand it. All right, let me just move it here. So relation, you can call it table, including number of columns or attributes, and number of rows or records. In the file term or terms of files, then we have fields and tuples. Okay. Now this data model terminology will be applied only to logical structure of the database. Only logical structure. You know that, right? We discussed this before. We mentioned that this can be applied in the logical and conceptual schema, not the internal, right? Not the physical. So this relational model will be applied to only the logical structure. I cannot. Okay, logical structure. I cannot select it because there is a text box. Okay, let's talk about the elements or the main component of a relation. See, this is a relation. Okay, there are two relations actually here. We have discussed this before, right? There are two relations. You can see here branch relation, and see it has a unique name. Okay, a unique name. So branch relation and staff relation. If you look at the branch relation or table, let's say, how many columns are there for the branch relation? How many columns for the branch table? We have how many relation? Sorry, how many attributes? Not how many relation. How many attributes for the branch or columns? How many columns for the branch relation? It's four columns. Okay, four columns for the branch, which are branch number, street, city, and postcode, right? So branch number, street, city, and postcode are columns or attributes. So attributes are columns. Alternatively, it can be known as columns of the table. And this is the relation. This is the relation. The name is branch. Okay? Now, how many tuples or how many records are there? How many tuples of this relation or how many rows, let's say? How many rows? How many records? B005. This is 1. See, I will show you. Okay, I will separate them. 1. How many now? Can anyone tell? For the first relation, how many records or rows? Yes, 1, 2, 3, 4, 5. Because we cannot count this as a row, right? Yes, exactly. So it's 5. 5. So 5 rows for the first relation branch. And this can be known as cardinality. What is the meaning of cardinality? The number of tuples a relation has. The number of tuples, or let me just put this, the number of tuples or number of, this is tuple, the number of tuples or rows. This is something like row, okay? Or also we can call it record. At the point, so if I ask you, what is the cardinality of the branch relation? What is the cardinality of the branch relation? Yes, anyone? We said the cardinality is the number of tuples. All right, so what is the cardinality of this relation? So cardinality is number of tuples. All right. So what is the cardinality of this one, the branch? Cardinality is, you said, how many tuples, how many rows? 5, right? 5, exactly, Batul. So the cardinality of the branch relation is 5. Okay, we have another term here, degree. Degree means the number of attributes, number of columns, or number of attributes. So what is the degree of the branch relation? What is the degree? What is the degree of the branch relation? So the degree is number of attributes. Yes, anyone? What is the degree of the branch relation? What is the degree? 4. Yes, Batul, thank you. So the degree of branch relation is 4. Why 4? Because depending on number of columns or attributes. So these are attributes. Let me just write here. Attribute. attribute or column or field. Also, we can call it field, right? Field. All right. Now, got the point? Got the point here? So this is attribute. All right. Now, let's talk about the second relation. Yeah, there is something very important here. The primary key of the, what is the primary key of the first relation? What is the primary key? As you can see here, it's branch number. Excellent, Ali. So it's a branch number. This is the primary key. It's like the key or the door. Let's say, if we want to understand it more, it's like the door that opens the branch relation, okay? So it's the primary key. Here, this is the primary key. All right, let's move to the second relation. Now let's talk about the second relation. What is the name of the second relation? It's staff. This is a unique name. Okay, and what is the primary key of the second relation? The primary key, it's what? What is the primary key of the second relation, which identifies this relation, which uniquely identifies this relation? Because it's staff, so it's, yes, exactly, Rashid and Batul. So it's the staff number, okay? So it's the staff number. Now, what is the link between both relations? We talked about this before. We said if we want to ensure a link or a relationship or association between relations, all right, to ensure data integrity and data consistency, we can have what? A primary key, right? So the primary key for in the first relation will be linked to a foreign key in the second relation. All right, so the foreign key in this case is a branch number. In the second relation, this is the foreign key, which ensures that there is a link between both relations. So this is the foreign key. It will give an association between two relations. Okay, let's talk about the second relation. I'm gonna ask you, what is the degree of the second relation? What is the degree? What is the degree of the second relation? Yes. Okay. Just let me. Are you sure, Mariam? The degree of the second relation? Is it only 6? You know that the degree is number of columns, right? A degree of any relation, degree, if we said degree, yes, Batul. So it's, yes, Mariam, it's 8 because there are 8 attributes, right? So the degree of staff relation is 8, if I ask you. I'm sorry. So the degree of the second relation is 8. How about the cardinality? The cardinality of the second relation. How many records are there? How many tuples? That's the cardinality. Exactly, Batul. It's 6. We can see 6 rows, right? We can see 6 rows inside this relation. The staff relation includes SL21, SG37, SG14, SA9, SG5, SL41. These are records. These are tuples or records or rows. So the cardinality of staff relation is 6 based on the number of rows or number of tuples. All right. Now you know the terms related to the relations or relational model. If I give you, for example, any other example, you will be able to identify the degree, identify the cardinality, right? So there are so many activities actually. I will provide you some activities related to this, and it will be easy, simple, inshallah. So don't worry. Now, attributes can appear in any order. Order has no significance. Okay. So, for example, if it is name, first name, last name, it can be appearing in any order. There is something we call domain. So if every attribute has a domain, for example, a specific domain. So what is the meaning of domain? It means the set of allowable values for one or more attributes. So for example, what is the domain for branch number? What is the domain name for branch number? Branch number, the domain name is branch numbers. And what is the meaning of this domain? It means what is the allowable values for branch number? It's all possible or set of possible branch numbers. What is the definition? How we can define it? It's character size 4, for example, range from B001 to B999. So this is the meaning of domain. You get the point? See, for example, this the branch number here. The domain of branch number can be identified this way. So, for example, the domain for the branch number is, it can be a number or character. The size is 4, and it ranges from B001 to B999. Let's take, for example, date of birth. What is the domain of date of birth? The domain for the date of birth, see here, it's possible values for staff birthday. All right, and how we can define it? It ranges from its date. The type is date, and it ranges from 1st of January 20, and the format DD, MMM, YY. So this is just an example, just to clarify the way that we can understand domain or attribute domains. So what is the domain? It's a set of the allowable values for one or more attributes. Got the point? Got it? This is the meaning of domain. So every domain, for example, let's take here, and this example, street. It's a character, and we can, the domain of street, for example, is set of all allowable addresses, right? Addresses lines. So street means like address number. Sorry, this we have city. So street only all set, the set of all allowable street numbers, let's say. Okay, and then we can have a size. How many characters we can allow this record to accept, or this attribute to accept. And then we have, for example, postcode. Same, we can identify the size. We can also the type, which is character, for example. All right, so this is the meaning of domain. The domain for position, can anyone tell? What is the domain of position attribute? Yes? It's set of all possible or allowable positions, right? Positions. And it can be character, and it can be also selected from a drop-down list. This is something we can identify in the domain. All right? So this is the meaning of the domain for the attribute domain. Now the structure for the table with the specification of the domains or any other restrictions can be done as intention. So what is the intention here? Intention is the structure of the table, or intention means it means, or we can define it as, the intention is the structure of the table, the specifications, of the domains, all right, and restrictions can be known as intention. So it's fixed. The intention is fixed, all right, unless the relation is changed and have more attributes or additional attributes, but it's fixed, all right. So the intention is the structure of the table and any associated specification or domains and restrictions, while the extension is, can be defined as the tuples, all right, the tuples, and it can be changed. It's changeable. So got the point? The structure for the table, the structure, the specification of domains, the attributes, and so on, can be known as intention. So what is the intention for this relation, for example? What is the intention? See, the intention for the branch relation will be the structure is including 4 attributes, all right? And these 4 attributes have some specification and restriction. There is a primary key, branch number, all right? The domain for each attribute, these are fixed. So the entire structure of the relation or the table is intension, and it's fixed. How about extension? What is the extension for the branch number? Sorry, for the branch relation or table, what is the extension? These are tuples. All right. So what is the extension for the branch number? How many tuples? We have 1, 2, 3, 4, 5. So 5 tuples, and it can be changed. It can be more. It can be increased. The number of tuples can be increased. So it's changeable. Okay. So this is the difference between the extension and intention. Intention is fixed. Extension or the state of the relation is changeable. We mentioned this before. We said the degree of any relation is the number of, so the degree is the number of attributes. Okay, and you give the number of attributes in a relation. It can be unary. Unary means, what is the meaning of unary? Unary means it includes only one attribute, right? Okay, binary, 2, right? 2 attributes. So if I ask you, for example, I give you a relation and it includes 2 attributes only, 2, and I ask you, what is the degree of this relation? See here, this is the, assume that this is a relation, okay, and it includes, for example, this. Okay, I ask you, what is the degree of this relation? What is the degree? You can say either, you can say 2, okay, 2, or alternatively, yes, exactly, Mariam, you can say binary. So the degree of this relation is binary. Okay, or if it includes only, assume that it includes only 1 attribute, you can either say 1 or unary. All right. How about if it includes 3 attributes? So what the degree of this relation is ternary, or alternatively you can say 3. Exactly, Batul, yeah. So 3, or any number, it can be n-ary, number array. Okay, so that's the meaning of the degree of the relation or relation. The degree of relation or relation is a property of the intention of a relation. Property of the intention. Why? Because we are talking about attributes or the structure of the table. All right. So the degree is the property of the intention, while the cardinality, which we say it's the number of tuples in a relation. All right. So the cardinality is number of tuples in a relation. We said it's the property because of tuples. So it's a property of extension. Okay, of a relation. Extension means tuples because it's we are talking about tuples, which is changeable over time. Okay. Now we can discuss the definition of mathematical relations. For example, if we consider two sets, okay, D1 and D2. All right. The definition for mathematical relations. D1 and D2. D1 includes 2 and 4. Okay. D2 includes 1, 3, 5. What is the Cartesian product? You studied this before? Have you studied this before? Cartesian product. The D1 and D2 is set of all ordered pairs. What are the pairs that we can get from both? D1 and D2, the product, the final product will be the first element is a member of D1, right? The pairs that we can get from both for example, sets. The first element, this one, will be a member of D1, right? The second pair or element will be a member of 2, right? D2. So how we can, or what is the final product or the Cartesian product from both if we take them all? So from 2, then 1. All right, then 2, then 3. This is the second set. The third one will be 2, 5, right? Then again, we will move to the second element, 4, then we take 1. Then we will take 4, again 3. Then 4 and 5. So this will be the final. This will be the final product. Okay, from both sets. Okay, now alternative way to find all combinations with first from D1 and second from D2. Okay, so I think it's the same. Let we just discuss this for the relation, how we can have it for the relation. So any relation, for example, a relation will include any subset from these two. Okay, any subset. For example, a relation can be 2, 1 and 2, 4, or 2, 1. Sorry, not 2, 4. 2, 1 and 4, 1. For example, this is a relation. Any subset of Cartesian product. Any subset of a Cartesian product is a relation. For example, from that one, the first, this combination, okay, from this one, we can take, for example, this one, 2, 1, 2, 3. We can call this relation. So any subset, all right? You can give me any example. If we take, for example, 4, 1, 4, 3, we can call it this one relation 1. We can call this relation 2. Okay, and so on. So any subset of this Cartesian product, we can call it a relation. All right, so we can specify which pairs are in a relation or in relation. We can have some conditions. For example, if the second element is 1, second element must be 1. We can have this condition. How we can write it, how we can write this as a rule, we can say R, which stands for relation, equal, the first element will be X, the second element will be Y, X from D1, Y from D2, and Y if this condition will be applied. The second element is 1. Okay, got the point? And y equal 1. This is how we can have it here. See. Okay. If we have some conditions, we will have, for example, if the second element is 1, how we can represent the relation as a rule. R equal xy. X belongs to D1, okay, or a member of D1. Y is a member of D2. And in case of this condition, second element is 1, how we can represent it? We can say y is equal 1. Y equals 1. All right? So this is the second element, which is y. Now, in another condition, if the first element is always twice the second, this is easy and simple, I guess. So you can say another relation, we will call it S, for example. It will include X and Y. X is a member of D1, Y is a member of D2, and X is always, with this condition, is always 2Y, okay? So X equals 2Y. If I give you, for example, these conditions, you can do it. You can, for example, translate it or represent it as a mathematical relation. This is the mathematical relation representation. You can do it. If I give you, for example, I give you D1 elements or sets, D1 and D2. D1 is 2 and 4. D2 is 1, 3, 5. Okay. Then you can get the Cartesian product. It's easy. You can just take the first element from the first set, D1, and the second element from the second pair from the D2, and then you will get this. Okay, the final product or the Cartesian product. Then I'll give you statements. For example, the second element is 1. You can write it this way. Okay, so this is the mathematical definition of relation. Okay, here are other examples. Consider 3 sets, D1, D2, and D3, with Cartesian product D1, D2, and D3. D1, 1, 3, D2, 2, 4, and D3, 5, 6. You can get the Cartesian product for all as 3 sets, taking from each set. Any subset or the triples is a relation. Any subset of these triples is a relation, and you can have many conditions over these. So in general, Cartesian product of n sets, D1, D2 to Dn, is D1, D2 to Dn is equal to these subset. Okay. Usually it's written as n x d1 and then I equal 1. So any set of n tuples from this Cartesian product is a relation on the n sets. This is the meaning of, or the definition of the relational or the definition of relations or mathematical relations. Any questions, you guys? Any questions? Do you have any difficulty? Next time, inshallah, I'm going to provide some examples for the mathematical definition relations, or the mathematical definitions of relations, or the mathematical relations definitions. So you will get more to know. You will have more understanding or have better understanding about it. Do you have any question for now? Any question? All right. I'll give you some examples next time, inshallah. It's easy, nice, or maybe like challenging. It's a nice way to understand, to have some examples. So next time, inshallah, we are going to have it. And that was all for today. Thank you so much for attending. See you next time, inshallah.